So let's do another proof. Let's prove, so before we showed that additive identities were unique, what about additive inverses? So there's a couple ways we could show that something is unique. One way is we could sort of give an argument by saying, hey, let's assume it's not unique. Let's assume there are two, and we'll come to a contradiction by showing that they're the same. However, we could also think about that by saying, hey, any two things that act like an inverse must be equal. And that's another way of thinking about basically what amounts to the exact same proof. But if we could show that any two things that amount to being inverses are equal, then there can only be one. And that's sort of the standard thing. So a standard way of doing it that doesn't rely on the ha-ha, a contradiction at the end. We could sort of just show that, hey, any two things that act like this must be the same, so there can only be one. Okay, let's do that now here. How do we do that? Well, let's assume that v plus a equals v plus b equals 0. So we're assuming that a and b both act like inverses to v. And what I want to do is I want to show they're the same. So what do we know? Well then, since this is equal to this, I know, well, I'm going to have an objection to this as soon as I'm done writing it, so don't worry if you're already objecting. Okay, so then I say, hey, then if I take the additive inverse of v and I add it to the left on both sides, the two sides are still equal. Yes, but the whole thing is we're not assuming that there is a unique additive inverse. So we could take either one. We don't have to do it like that. What we can do is we could say, okay, then pick either one of these inverses. Let's pick a. And in order to be proper, we still have parentheses like that because that's what we had before. So what do we have? We have a plus v plus a is equal to a plus v plus b. And since a is an additive inverse, we don't need it to be the only one. It's an additive inverse. So what happens when I apply it to v? Since it's the inverse of v, this goes away and gives me 0. So I get 0 plus a. I get the now unique 0. We know that's unique. And then, since 0 is the identity, I get that. So I'm done, and I've showed uniqueness here. Okay. So what else do I want to show? What else can we prove? Well, we can say some more stuff about zeros. For example, how does the 0 scalar interact with vectors, and how does the 0 vector interact with scalars? We could ask questions like that. Let's say if v is a vector, what happens if we apply the 0 scalar to a vector? And this is a confusing statement here. Okay, think about what's here on the right. And it's just confusing. I'm not saying you're confused. I'm saying notationally it could be confusing. 0 acting on v, what is this? Well, this must be scalar multiplication. We can't multiply two vectors, so this has to mean the scalar 0 times the vector v. And what does this have to mean? It has to be a vector, because a scalar times a vector is a vector. I guess if I wanted to, I could just try to doubly indicate that that's the vector in our vector space. However, it's sort of hard to do bold unless I sit here circling this over and over again like some sort of a, I don't know, angry person that's angry at the number 0. In any case, let's try to show this. Let's try to show this is true. So I want to show that this is equal to that. So let's start with the left-hand side. Now remember, two tricks I like to say. Multiply by 1, probably not going to use that here. This is a proof about zeros. So let's try to add 0 in some way. And what can I do? Well, one thing I could do here is I could say, okay, I want to add 0. So I can add 0 like that. Now you see, keep in mind I can't just add the 0 scalar to 0v because we can't add a scalar and a vector together. And I could try to bring in the 0 vector right here, but I don't necessarily want to do that. Why don't I want to do that? Because I know that the 0 I have here is a scalar, so I kind of want things to work out in some way with that. So what do I have here? Well, the only thing I have is the distributive property. Look here. Whatever 0v is, what could I do? Well, I know that this is equal to this. So I can say, adding the additive inverse of this vector, whatever that is, to both sides. And you guys know the associativity bit, so I think it's okay if we assume that we all understand that this is associative when we add to both sides here. So what I'm going to get is I'm going to get this. And that, well, since these are inverses of each other, gives me that here. And since these are inverses of each other here, and lo and behold, well, when I apply this, 0 vector to anything is going to give me that thing. And I am done. I have shown what I needed to show for this situation.